Um, yeah, so here to make some shit. Quality of the last try was pretty bad, but let's be honest, that's the thing you're supposed to expect by now. Alright, so I got this idea, I think last night where um, I thought of making like this thing where there's this website. It's famous. So wait, what was the website? Chemistry notes or some shit. Chemist something about it's like they were doing so basically it's like a simulator but for chemistry experiments. And I thought, hey, we need to make a game like that for bioinformatics shit, like somewhere where we can make dinosaurs shit like from Jurassic Park. And yeah, I never made a game, so yeah. Alright, let's see. Godot. Bro. I never used Godot. I don't know what I'm supposed to do. Tutorial. Fast. Okay. Godot document. This one? Wow. No, I'll try to do in a methodological way. Yes, that's the word. Because a lot of times what happens is you get inspired by something and then the candle burns bright and then the brightness fades away or something. Let me see if I'm actually fucking live. Will I get copy strike if I play my own stream on my stream? 55 minutes ago? What? I wasn't streaming 55 minutes ago. Yeah, okay. So let's open Paint and I'm gonna tell you how we're gonna do this, how I want the final product to look like. It will change like all things. But so it's gonna be a first person thing. Think like cooking simulator, right? It's gonna be first person and there's gonna be like a computer that and it's gonna be like once you enter the computer, it's gonna do the whole screen, and then you can see like A, B, C, other like bioinformatics shit, right? And then you can do things like order DNA, or maybe we can make DNA or some shit like that. So they can synthesize it, making a DNA synthesizer. I don't know the whole fucking what's it called? The process, but we're gonna do that. And then we can like do the wet lab stuff, like things like centrifugation and shit like that. And all of this probably will have like PS1 graphics, what's the place that does the thing, fucking horror games, the guys that do the horror games. Okay, you know the ones, like the Nun, game and stuff. The Night Reaper, was it? Yeah, those guys. So it's gonna be like that. Um, and it's gonna have PS1 graphics because I can't model for shit. So today we'll have some goals. We'll try to see how to get the first person working with the camera and shit. First person. I never coded in Godot by the way, so I don't know jack shit. Then we will also try to do some interactables. And okay, we need three goals because three is like the magic number always. Hmm. Okay, we'll figure it out. Good. Okay, let's see. Three. Because we wanted to be three. I will try to use AI as less as possible because I don't want my brain to be rusted. God damn, it takes a fucking minute. My internet shit or it's going fine. Okay. No, no. Is there anything like first person? Because I want it to be first person. First three game, third person, first person. First person. See, I already searched up for this shit, but I don't like watching YouTube videos. Yes, we have to. I think I'll watch this one because the other one just gave you like the GitHub things. They're really helpful, but what's the point? So I think I remember is to. Alright, this is sort of 3D scene, and then add a mesh. So yeah, okay. Mesh instance, yeah. Then you put a plane for your mesh instance. Is that a child node? Is it here? Somewhere over here. Mesh. Shit. Shit. Mesh. Ah. Okay, we need a plane. Yeah. Change the size of this plane. Okay. 20. There you go. Then we add another, which is this character. Is it character body or player body? I think it's character body. And then character body, and under character body, we add a mesh collision shape. Collision shape. We have caps. Right? Look like okay, kind of. We need a mesh again. I think. Right? The shape. We need a mesh. So we do another mesh instance. Yeah, yeah. Okay, okay. Caps. Right? I think so.
To be our floor. So to be a large flat area, we can choose a plane to be our mesh. In the inspector on the right, with that mesh instance selected, there is a mesh property that's now visible. You can click the drop down to the right of it here, and you can select a new mesh there, or in our case, a new plane mesh. This plane mesh is about 2 meters across. We want that to be a bit bigger so we've got some more space to run around, so let's increase the size to
What's going on with my stream? What? Oh, it's my game capture.
20 by 20. There we go, we've got a big old plane now. If we click this mesh button at the top of the viewport with that mesh instance 3D selected, we get some options for useful default actions.
We didn't do this. This one, yeah, mesh, then create.
For mesh instances. And the one we want here is create try mesh static.
I remember getting that option. Oh, collision? Okay, I think it's this one. Static body. Okay,
Body. What that will do is it will create a static body and it will create a collision shape in
click
the
try
same shape
mesh.
as
I'm gonna
our
assume
plane.
it's try mesh.
So I click that straight off the bat, we get a static body and we get a collision shape.
Did we get that? Static body and collision shape. Yeah, we did.
And that will let our player stand on that and not fall through. So now that's set up, we can create our player. You have a few choices for nodes that are useful for creating characters. Either character body, if we go to body in the add node section, if I search body in create new node, you can see we get character body and rigid dynamic body. I really like using rigid dynamic bodies, but the staple for creating characters is character body. Rigid dynamic body has lots of physics built in, so it's useful for things like bouncy balls or projectiles or things that you want physics to interact with. So if you want a character that ragdolls, it's useful. But the standard is to use a character body because you get a lot of fine-grained control over how the player will move. So let's create a new character body, and we can add a mesh that will be our player's body as a child of this. So with that selected, hit Control A again, and let's add a mesh instance. And this time the mesh instance can be a capsule. Beans are the most common staple in game dev for creating a player character. So here's our bean. You'll notice our bean is clipping through the floor at the moment. We can just select our character body and click the green arrow and drag to move everything up a bit so we're not clipping through the floor anymore. Now, in the same way as we created our static body, we need to create a collision shape for our player so that they won't fall through the floor. With this capsule selected, let's click that mesh drop down again, and then this time let's create a simplified convex collision sibling. We don't want to create a collision shape that's perfectly rounded, it's just going to have a lot of needless triangles. So when you create a simplified one, if I just hide that top bit, go forwards a bit and look around, you can see at the top here.
What the fuck is happening? I'm not a dumbass. I can do this shit. Okay, I can move it. Okay, cool. I think this should be fine. See, he got the same
We've
thing.
just got a much more simplified shape, it'll be more performant. So we've got our player.
Mesh instance 3D, and then we have collision shape. Yeah, we do. It's all in the same order, but I don't think that should matter.
We've got their mesh and we've got the collision shape.
Yeah.
Now we can dive into adding a camera that the player will be able to look around with. The camera is going to need a pivot to tilt around that's going to act a bit like a neck or a head. So let's add a node in the middle that can just be a node 3D, and I'm going to call that neck. If we double click on the node itself over here on the left in the scene tree, we can type in a name, so I'm going to call that the neck, and I'm going to move it up a bit. And that's about where I'm going to position the camera. It's also worth noting the camera is going to be inside of the beam. Interior faces cull by default in Godot, so there's no risk of us seeing the beam from the inside, although there is stuff we can do to make the outside of the beam invisible to the camera if we wanted to make the camera move around a lot. But in its current state, there's no risk of seeing the beam from inside. So now we've got that neck at the right position, we can hit Control A again, and we can
My character stuck.
add a camera 3D. And you'll see we get...
Man, I keep getting... Okay. Keep getting distracted, dude. Okay, add child. 3D. 3D. Shit. Go into net. Okay.
move around.
This sucks, dude. Holy shit. Yeah, it's because I'm filming.
We can do to make the outside of the beam invisible to the camera if we wanted to make the camera move around a lot. But in its current state, there's no risk of seeing the beam from inside. So now we've got that neck at the right position, we can hit Control A again, and we can add a camera 3D.
Camera. Okay. We're getting somewhere.
And you'll see we get a magenta shape indicating where the camera's looking in the viewport here.
Is it clipping?
And if we click this preview button in the top left, we will be able to see what the camera can see currently, which is parallel to the floor view, straight in the negative Z direction. So we're now at a point where we can try out our scene and see how things look when we run it. So if we click this play button in the top right, or F6, which runs the current scene, it will prompt us to save our scene. I'm going to call it 3.
Save this. Where do I save? Okay, fuck it. Okay, game started. Will I be able to move? No. Okay, makes sense. I don't think you'll have to code it out.
3D level. And now we can see our game running. There's a key problem though, and that's that we don't have a world environment set up. As a result, there's no lights or information on how all the materials should be presented to the player. This can be quite confusing because in the viewport we can see there is all this information and lighting already there, and that's because scenes in Godot have a preview environment that's set up just to make things easier to develop in without needing to add an environment to every scene you work on. We can add that preview environment to our scene with the 3 dots at the top of our viewport. So if we jump back into here and we click these 3 dots, you'll see we get a preview sun and a preview environment panel. On the bottom left and right, there are buttons to just add those straight into our scene. So we can click add sun to scene, we can open it up again, and we can click add environment to scene. And now
Okay. This one here. Okay. Should be bright. Yeah. Okay.
You'll see in the top left of our scene tree, we have a world environment and we have a directional light. Now if we run the scene again, it will look as we expect. This is one key change from Godot 3 to Godot 4. In Godot 3, there was a default environment in the file system that had this information that would automatically run in every scene you run. That was removed to make the file system less busy, but it means you need to know about this approach to adding environments. So now we've got our environment and camera set up, we can start focusing on making our player move. If we click on our character body, and then we click this little picture of a scroll with a green plus at the bottom right, we can add a new script to that character body. This is what's going to control how our character moves and how our camera works.
Okay.
And one of the other nice things in Godot 4 is there are templates for scenes built in. So right off the bat, if I click create now, there's this template for basic 3D movement. I'm going to want to name this script quickly to player, and then click create.
And oh, okay, that's fine. Oh, well, I know a little bit of Python. This shit looks a lot like Python, maybe.
You'll see we've got a
Try
full
not to use
script
AI.
already in here, about 32 lines long total. And what this does is it allows our character to move and jump with the arrow keys and spacebar. And even just with that, if I run the scene again, you can see I can move left, I can move right, I can jump, I can do all those basic things. Which is nice enough, but the arrow keys aren't really ideal. We probably want W, A, S, and D. So to change the input to use those custom inputs, we need to go to Project in the top left and jump to Project Settings. When we're in there, there's a tab called Input Map. Here's
Wait, can't I just change it in the code, or do I have to do that? Can't I just like instead of putting UI left, put it as W? I don't think it works like
where we can define new inputs by their name and assign what keys control them. So we can have a forward action, a back action, a left action, and a right action. And then for each of those, there's a plus on the right. You can click add event over there and enter the input event you want to control that input event.
that. How is this? No. Okay. I think you'll have to
Event over there
call
and enter
this.
the input event you want to control that input event. So if I hit W, whenever the player presses W, we will get that forward input event being fired off. So let's click OK and let's repeat for the rest of them. So for back, let's add B.
Alright. Okay. Action, so forward, back, left, right. Okay, forward. Okay, done. Yep. Back, left. Right. Yeah. Okay.
For left, let's add A. And for right, let's add D. I must have said D twice there, I'm almost certain I did. For back, let's press S. Okay, so now if we scroll down in this bit of code that's already made for us, there's a part where they get our input direction, this var input
Mm.
line. It then takes a bunch of inputs defined by us and will create a two-dimensional vector that represents the way we want to move based on those inputs. So at the moment, if we just swap out the inputs for our new ones, it will just work as it will work as it did previously, but with our buttons. So let's replace UI left with left, UI right with right.
Okay, so it's this. So is it like these? Probably. Okay, it's all caps. Okay. So forward. This is back. Okay. Do I have to save this?
Up
Or
with
is
forwards
that?
and down with back.
Hmm.
And now if I run, W moves forwards, S moves back, A moves left, and D moves right. Okay. Now all that's left is getting the camera hooked up. So our
Wait,
camera
wait,
has
wait,
to
wait, shit.
now left and down with back. And now if I run,
Hell yeah. I got the best. Me. I fall off. Yeah, I'm falling. Okay.
W moves forwards, S moves back, A moves left, and D moves right.
We need.
Okay. Now all that's left is getting the camera hooked up. So our camera has a neck pivot. That's because we want to keep the way we're rotating left and right separate from the way we're rotating up and down, because we're going to use the way we're rotating left and right to figure out what way forwards is, and we're telling our player character to move. So if I go up to the top, we need to define the two nodes we want to get access to, that being the neck and the camera. Godot 4 uses annotations to do this. There is an @onReady annotation that replaces onReady from Godot 3. And after that, we can define a node and then the path to it. So we can define our neck as var neck, and that just defines it as a variable. And colon equals will assign a path and guess the type of the object we're assigning to it. So this is going to create a neck that's got the right type for what our neck is, which is a node 3D. We can then get a path to a node in our scene tree with the $sign, and then if I type neck, it should auto-complete. So that path is relative to our character body node.
Okay, so you're basically
Our
saying.
neck
Ah,
is
goddammit.
a child of it, and it's an immediate child, so its relative path is just the name of it. We then want to do the same thing for the camera. This time, though, its path is neck/camera 3D because it's a child of the neck. If you're ever confused about what a path is, you can just drag it straight from the scene tree into the spot you want, and it will put the correct path.
Okay.
And then let's rename this variable.
So you gotta access these variables. Okay, I got that part. So what do you put the function? You put it on the function because I think you put it outside the function because you gotta put it everywhere else, right? Okay. So already variable now equal to minus
variable to camera. Now we have those two variables, we want to handle capturing input events from the mouse. We do this with a virtual function called unhandled input. So what unhandled input does is it listens for every input event that happens, and it calls it for every function that has an unhandled input event virtual function, and we can narrow down what the event is to figure out what just happened. We want to capture the mouse, so we can actually listen to what way it's moving left and right. We can capture the mouse with this little bit of code here.
Damn it. No wonder people use AI. I'm too lazy to type all this shit. Unhandle input. Why is it all green for me? Okay. So basically, it's like if input. Okay, if this event. Okay, this input event move button. Wait, let's basically click. Input set mouse mode. Input mouse mode capture. Can you explain?
We want to start by checking if the event is an input event mouse button. So what that means is if we have clicked any button in the game window, we want to start capturing the mouse, and that means the mouse cursor won't be visible and freely moving around the screen. Then afterwards, we also can check if they've pressed UI cancel. This is the escape key. This lets us free the mouse, which makes it a lot easier for testing, so we can actually click the close button.
So if the if event is input mouse event mouse button input dot set mouse input dot set mouse mouse dot set set no set mouse mode yeah mouse why is set mouse mode not a thing set mouse I don't know. Okay. Yeah. Okay. Dot mouse mode captured. So input dot mouse mode captured. Ls. Wait. The event is dot actions. Event dot is action. Okay. Is action pressed escape UI cancel. Cancel. Is input dot set mouse mouse input dot mouse mouse
The window and the like. So if they press the close button, we just make the mouse mode visible again. Now we're capturing the mouse, we can listen to mouse motion events and rotate the neck and camera in a matching manner. So I can then go and add this little bit. and we can check if the mouse mode is captured. So if the mouse is actually being listened to, we can rotate the neck relative to the relative mouse motion. So whenever an event is an input event mouse motion, we will get a relative property. If you hold control and click on input event mouse motion, it will go into the documentation for that specific object, and you see we get a property called relative. This relative property gives us an x and a y value for how far our mouse has moved, either left and right or up and down, in this specific input event. So if we go back, we subtract.
If is input dot get names. So if wait, so it's input dot set makes sense. Get mouse mode is mouse mode captured. And if input event mouse motion, so you need to apply it to mouse, so you need the neck as well. Dot rotate relative. Rotate y. Minus event dot relative. I'm gonna assume that this should work if I finish my thing.
How far we've moved left from rotate y, and that means that our neck will rotate left when our mouse moves left, and will rotate right when our mouse moves right. We want to multiply that result by a very small.
Do I get an error? Silent. Does it have to be silent? Does not allow inside an expression. What's this one? I'll see how that works.
Number because this will rotate in radians. So about 3 is almost a full rotation. And our mouse moves in multiple pixels at a time, so we'll be doing multiple rotations at a time. You can just fiddle with what a sensible sensitivity would be, export it as a variable, whatever you wish. I just multiplied it by 0.01 and it felt about right. After we've rotated the
Lady moves.
neck left and right, we can rotate the actual camera up and down. And we will do exactly the same thing, but we will rotate the X property and we will use the relatives Y property because that's the amount we've moved up or down relative to the last frame. The last thing we want to do is limit how much we can rotate up and down, because if you rotate all the way up, you'll start spinning around backwards, and most necks stop at about straight up. So we can use a clamp function. Clamp is a built-in function that limits a value to be
Something about degrees to grad.
least, a minimum, and at most a maximum. So this will limit it so you can't be less than negative 30 degrees and you can't be more than positive 60 degrees. And we just pass our camera rotation.x through that clamp and update it. So now, if I just run that, I can
Works. Okay. It's very, very smooth. God. Okay. It's a little out of weird. This increases it by a lot. So, I really gotta fucking save this shit. And then what I do is that let's see. Guessing too much. I think we have to go with 0, 1 for now. It's still seemed some, yeah, so strange.
Move right, I can move left, I can look right, I can look left, and I can look up and down. And I can jump, and you've got pretty much
Why does it seem so weird? Still seemed
a whole character controller. But you'll notice a key problem, and that's no matter what way you look, forward is always
full.
in the starting direction,
Yeah.
left's always in the starting direction, and right's always in the starting direction, and back's always in the starting direction. So what we need to do is we need to make it so that when we push W, we go forward in the direction the camera's pointing. Now that's done with a basis. At the moment, our game script is calculating the forward direction using transform.basis. Basis is part of an orientation, and it pretty much tells us what way we think is forwards. And at the moment, it's using the root of our character, what way that thinks is forwards. What we can use instead is we can use what way the neck that we've rotated around thinks is forwards, and then move in that direction instead. So what we do here is we pass in neck dot before that. So instead of using the transform of our root character, we will use the transform of our neck instead, which has rotated into the appropriate direction. And we need to get rid of this colon because it can no longer infer the type.
Nice. Why am I still okay? Still seems weird. Something seems to be working. No, I'm not controls. Is it? No. I'm moving weird. Yeah. It's not how I'm moving.
And with that done, I hit F6 again. If I look right and I walk forwards, I'll go forwards. And everything is relative to our neck. And that's it. We've got a character controller that can walk around. It's all done.
It's not weird. seems to be the word. I go forward, turn, I go forward, I go backwards. Okay, forwards. Hey, look at that. We finished one of our goals. Kind of. See, does it feel like it's going to the side? See, now when I'm pressing it back, it doesn't go back. It goes to the side. Like I'm pressing S. It's going to the side. It's, damn. Oh, interesting. Hmm. Let's see. But I feel like now I'm going forward when I press my inputs are reversed. Let's see. Okay. Maybe it is maybe dumbass. Oh yeah, it is maybe a dumbass. This should be working nice. Okay. Okay, nice, 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 nice. Okay, nice. Okay, so we finished one goal, which is to make the first person thing. Right? Next is to make an interactable, something that's E, and if that block is colored, then changes color. That makes some. Yeah. Okay. So go to 3D
Okay, so if you've ever seen any of my past stuff here, you might notice that in my horror games you can pick up something like a bone or something similar to that. Today, I'm going to show you how to make interactables in Godot 4. So first, here we have a basic first-person controller. So if I go ahead and just take a look around my game, it's just a simple game where I can run around, but we can't pick up this little cylinder thing. So let's go ahead and make it so that we can pick this up and trigger some code. So first, to do that, you're going to need a form of raycast to determine where the player is like looking. So let's go ahead and do that. So here on our player, you can add a raycast, and we'll just move this, hold down control so it snaps, move it up. And what you're going to want to do here is figure out where center is for you. I'm sure there's a much more efficient way of doing this, but this is just the way that I did it. But that feels about center to me. And if you design your character like on the axis like this, then you should just be able to cut him in half and it'll always be dead center of the screen. It's just a matter of too high or too low. So now that we've got this, let's go ahead and just like extend this. So I'm just going to use this size tool from up here, or you can press R, grab hold of the blue or whichever side extends it, stretch it out just a little bit. See that? There we go. I kind of like that.
Of the line
That's good.
touches.
So this is now our interaction raycast. So basically the idea behind this is that this is going to return the first thing that it hits within its layers. So if we take a look at the collision mask, we have layer 1 and layer 2. So if we wanted to detect stuff from layer 2, then we would have to check that box here, and then it's going to return anything that it also sees on layer 2. If your interactables are on layer 2,
I'm gonna assume
but
that
you want to
the
make sure you
like
can't see through the
this.
walls to interact with it, you have to make sure that your physical layer that your character stands upon is also checked. So in my case, layer 1 is where the physical layer is. That's where you don't fall through the floor. For me, just for the sake of simplicity, I'm not going to check that right now. And then we can go ahead and rename this to like, I'm going to call mine CCast, and let's go ahead and make it unique. Okay, here in my first person controller script, I'm going to make some very simple changes. So pretty much just, I think here at the top is an appropriate spot for me at least. For you, just wherever it falls within your code. I'm going to basically say if my ccast dot is colliding is a property, which is going to return a boolean, then in that case, if it's colliding with something, right, we can actually get like what it's colliding with. So we can go ahead and create a variable for the target, and we're going to say that is the ccast get collider. So an important thing to also note is that raycast only intersects physics bodies. So anything that is a physics body 3D is going to be reported back. If you want to be able to intersect an area instead, so if your item is like an area, then, which would kind of be weird anyway, but you could just check this box that says areas, and in that case, any areas on that layer will also be returned within your raycast. So just whichever item is the first item is the one that's going to get returned. So I'm going to uncheck that. In my case, since we created the static body, that's a physics body, so it's going to return that. And so what we can go ahead and do here is we can just go ahead and print this out to the console. And let's go ahead and launch our game. So now when I look at the object here, oh, I see what's happening here. Okay, so with our debug options, if you go up here, you can enable collision shapes, paths, navigation, avoidance, whatever you want to see. So if you want to see collision shapes, you can just check this box here. Okay, see that right there? That blue, I believe, is actually our raycast that we're trying to get to intersect with this blue object here, but it's not. See, because you can see the outline here, and it's not intersecting because it goes directly out from our player, if you recall. So see how it goes straight? It's not actually attached to my camera. So I could just make it a child of my camera, which might crash my game like it just did. And now let's try that. Oh, that is much better. Oh, there we go. Now we're picking.
So recast. Cut this to what it is. Um, function adjusting. And let's try going to the yeah. So I add a raycast to this raycast 3D. Let's see. Raycast video today. Test the 3D. Just Raycast 3D.
Here, and then it's going to return up. And what you're going to want to do here is figure out where center is for you. I'm sure there's a much more efficient way of doing this, but this is just the way that I did it. That feels about center to me. And if you design your character like on the axis like this, then you should just be able to cut him in half and it'll always be dead center of the screen. It's just a matter of too high or too low. So now that we've got this, let's go ahead and just like extend this. So I'm just going to use this size tool from up here.
Raycast. I don't see it. Let's see my Raycast. Trying to see my Raycast. What the hell? Okay. Oh. Okay. Delete. Control A. They're the axes. Hmm. Okay. Keep
Or you can press simple changes. So pretty much just, I think here at the top is an appropriate spot for me at least. For you, just wherever it falls within your code. I'm
unemployed. Why isn't the question there? Okay. Um,
In this video, we're going to go over creating a complete modular interaction system. Let's go ahead and get started setting it up. All right, so I'm here in Godot, and the first thing we want to do is set up an input action and also a collision layer to handle all of our interactions. So I'm going to go to project settings and then just go to the input map tab and create a new event. I'm just going to call it interact. Click.
Last time, actually, last time, we coded the player movement so the player can hop around the map. And then we added fall damage so the player won't hop around as much. But look at the poor guy now. Aw, I know just the thing you need. No. No, that's for the next video, probably. Today, we'll code interaction. Hey, I'm Nagi, and I hope you've got some
Nagi, like from Glowlock.
popcorns and a notebook ready, cause this video is gonna be a long one. Before we start, let's check up on the homework I gave you in the bit weird, but I think the importance of an organized project structure goes a long way. Here, you can see I've separated all the different game mechanics into their own folders. Now, I can't say for sure if this is the best way to organize your project files, but from my experience, having game mechanics in self-contained folders makes it quite easy to transfer them over to different projects, if you wish to do so. Anyway, I'll create a folder and name it interact. This will store most of the code we write in this.
Come on, give me some good.
So today I'm going to be showing you guys how to make a press E to interact object. So pretty much all it does is it uses a raycast, and whenever you hover over an object, it displays the press E to interact. If you press E, it's going to say that it picked it up. So you can link this to all kinds of systems that you have in your project. So let's go ahead and get started on that. So the first thing that you want to do is I have this project template set up. You can go ahead and download it from the description. But all it is just a character body 3D that I set up with a basic movement script, and it has the raycast in there. And then it just has a level and some lights. So let's go ahead and look at that script for the character body. So the first thing that you'll notice is there's just a bunch of movement in here. The first few things is that we have a camera and the raycast defined. If we go over here to the player, you can see that I have my camera set up, and an interaction ray is what I called it, but it's just a raycast. It's positioned in the center of the camera. And so what we're going to have to do is in here we're going to have to create a script that's going to check if it'll hover over the object and display the label that we create, and then a few other things, but the main thing here is that this is going to be our interact, our activate. So let's go ahead and go over to project settings. We'll go to input map, and we need to create a new activate. So this one has left mouse button, but we're also going to need it to be press E to interact. So we'll go ahead and add that. If you don't have this in your project, it's pretty easy to add. Right here where it says add new.
Okay, but we've done decently. I think I got something down. It's, yeah, it should be fine. No, we got the moments down. I'm pretty bored. I want to play some Thomas the Tank Engine games. Well, I'll see you. Bye.